Hello everyone, this is SUJEEVANA, belongs to CSCA section of Adi Shankara Institute of Technology. Today I am here to explain threads in operating system. First of all, what is a thread? A thread is a flow of execution through the process code with its own program counter, system register and stack. Just now we heard about program counter, system register and stack. Here the program counter is used to store the address of next thread, and registers are stored to use some files, and stack is used to store temporary variables which we come across the execution. A thread is also known as a lightweight process. Threads provide a way to improve application performance through parallelism. Each thread belongs to exactly one process and no thread can exist outside a process. Here we have single thread process and multi-thread process. Single thread process and multi-thread process, we can come across only one difference, that is here only one thread is present and we have multiple threads in multi-threaded. But the similarity we can see is for one thread we have one register and one stack. Here for three threads we have three registers and three stacks. So by this we can conclude that each thread has its own individual register and stack. Now difference between process and threads. First, process. Process is heavyweight and consumes more resources. Threads is lightweight, as we discussed before. Thread is a lightweight process which uses less resources for execution. Second point is process switching needs interaction with operating system. Here from changing from one process to another process, we need the permission of OS. That means we need to interact with OS for the context switching. Here, but thread switching doesn't need interaction with OS, no need of operating system permission. The third one is in multi-threading processing environment, each process executes the same code but has its own memory and file resources. In threads, all threads can share same set of open files called child processes. The fourth one is if one process is blocked, then no other process can execute until the first process is unblocked. While one thread is blocked and waiting, second thread in the same process can continue the execution. Fifth point is multi-processors without using threads uses more resources. Multi-threads processors uses fewer resources. So the last one is in multiple processes, each process operates independently of the others. One thread can read, write or change another thread's data. Advantages of thread. Thread minimizes context switching time, because in thread context switching we need not to interact with OS, so that time is reduced. Uses of thread provides concurrency within a process. Concurrency in the sense executing all the threads at a time. So all the threads at a time are executed, then the time consuming is less, so the efficiency of the execution is more. Efficient communication, as thread can communicate with other threads, the efficient communication is present between threads. Economy, it is more economical to create and context switch threads. Utilization of multiprocessor architectures to a greater scale and efficiency. Disadvantages of thread. Blocking of parent thread will stop all child threads, as the child threads are arrived from the parent thread. If one parent thread uses block system call, the all other child threads are blocked at a time. And the second disadvantage is security. Types of threads. We have two types of threads present over here, user level thread and kernel level thread. User level thread. User level thread implement in user level libraries. These user level threads are implemented by user. So thread switching does not need to call operating system and to cause interrupt to the kernel. Here thread management kernel and operating system are unaware of the existence of user level threads. That means operating system does not know that there is a thread present. In fact, the kernel knows nothing about user level threads and manages them as if they were single threaded process. Advantages of user level thread. User level thread does not require modification to operating system. As we discussed before, the operating system is unaware of user level thread. There is no need to require modification. Easy to represent and manage. As the user level threads structure is simple, it is easy to represent and manage. User level thread can run on any operating system. By this we can conclude that user level threads are platform independent. User level threads are fast and efficient. Disadvantages of user level thread. There is a lack of coordination between user level threads and operating system kernel, because operating system kernel is unaware of the existence of user level thread, and this kernel does not know what type of thread is going to come into the kernel level. So there is lack of coordination between user level and kernel level. User level thread requires non-blocking system call, that is multi-threaded kernel. Kernel level threads. In this method, the kernel knows about and manages the threads. No runtime system is needed in this case. Operating system kernel provides system call to create and manage threads. In the before user level threads, the operating system is unaware of user level threads. But here, the operating system directly supports the kernel level thread. Before, in user level threads, we have thread libraries to create user level threads. Here we have system calls to create kernel level threads. Advantages of kernel level thread. Kernel can simultaneously schedule multiple threads from a single process or multiple processes. If one thread in a process is blocked, the kernel can schedule another thread of the same process. I can explain this point with a simple example which we come across in our examination hall. Whenever our front bench student is absent for exam, the invigilator asks us to occupy his space to move forward. This is the same exact scenario which is going on in kernel level thread, because if one thread is blocked, kernel can schedule another thread in place of blocked thread, so that the execution is continued eventually without any interruption. Kernel routine themselves can multi-threaded. Disadvantages of kernel level thread. Kernel threads are generally slower to create and manage than the user threads, because kernel's structure is very complex, so it is difficult to create and manage kernel level threads. Kernel requires thread control block for each thread in the pool, hence complexity increases as each thread should carry a thread control block, so the complexity even more increases. Difference between user level thread and kernel level thread. First, user level thread. User level threads are faster to create and manage. In the kernel level thread are slower to create and manage. User level threads is implemented by a thread library. Here kernel level threads are implemented by system calls. User level thread is generic and can run on any operating system. इसका मतलब है this is a platform independent, but kernel level thread has a particular operating system. It's a platform dependent. Multi-threaded cannot take advantage of multiprocessing. Kernel routines themselves can be multi-threaded. Here multi-threading models. Some operating system provides a combined user level thread and kernel level thread facility. Solaris is a good example of this combined approach. Multi-threading models are three types: many-to-one, one-to-one, and many-to-many model. Many-to-one model. 1 minute. In many-to-one model, implementation of many-to-one model in the sense mapping the one kernel level thread with more number of user level threads. Here we can see the user level threads, and this is the only kernel level thread. The disadvantage of many-to-one model is, as we have only one kernel level, if this kernel uses block system call, let me draw here. These are the kernels, and this is user level, and this is. So this is the only source for all of these user level threads. If this kernel level thread blocks, so there is no source for these user level threads for execution. This is the disadvantage of many-to-one model. And now one-to-one model. Let me use a pen. Yeah. here one-to-one model in the sense we can, let me draw. This is one user level thread and we have one kernel level thread. We have one user level thread and we have one kernel level thread. If the advantage of this is, if this kernel uses block system call, only this user level thread will be blocked. So these can continue with this kernel. So we can avoid one is block. We can avoid block system call. And the second one is, the first one, we can't execute the threads concurrently in the sense at a time, because one kernel level is accessed by many user levels. So only one user level can access one kernel level. So the concurrency is missing. Here we have one user level for one kernel level, another user level for one kernel level. So all the user levels can be executed concurrently. So we came across concurrency in this model. Yeah, now many to many model. Here we have more number of user levels and more number of kernel levels. Here more number of user levels are mapped with more number of kernel levels. If one kernel uses block system call, these all user levels can make use of the remaining kernel level threads. So here also we can use block, and the concurrency is present here also. So this is the end of the tech talk. Thank you.